Good morning, everyone. I am Denver Cantor, first year computer engineering student. So today I will talk about definite integration. But first, what is the difference of definite integration and indefinite integration? Indefinite integration is obtaining the antiderivative of a function, while the definite integration is obtaining the definite integral of a function. So, when we are talking about definite integration, we are talking about its formula. So, what is the formula of definite integration? This is the formula of definite integration. The integral of f of x dx is equal to f of b minus f of a from a to b. This is the formula of definite integration, where f of b is the integral of f of x at b, and f of a is the integral of f of x at a. So when we are solving equations and functions from definite integral, we will gonna use this formula, because when we won't use that, we can solve definite integration. So what is the use of definite integration? The use of definite integration is simply like solving the area of the curve on a plane. We will solve the area of the curve on a plane from A to B. So we will solve this area of a curve, the exact amount, precise and correct amount of its area. That is the use of definite integration. We will use this formula to solve the area of a plane. That is the simplest way to explain on what is the use of definite integration. So, now we know the concept of definite integration, we will proceed to examples. Our first example is the integration of 5x minus 4 squared from the limit of 2 to 3. So, on this example, we will use u substitution. So, when using u substitution, we let u is equals to this function 5x minus 4. And the du is equal to 5 dx. And when we are solving the dx, we will just divide both sides by 5 to cancel out the 5 here on dx. So when you cancel it out, the remaining one will be dx, and the value of dx is equals to du over 5. Now that we substitute our equation into the u, or we u substitute it, we'll proceed in solving. So, integral of, since we let u be the 5x minus 4, we will use u. Copy the exponent. The value of dx is equals to du over 5. Always remember that thing. Du over 5 from the limit 2 to 3. 2 to 3. So, we can also simplify it by making it u integral u squared over 5 du from the limits of 2 to 3. Now that we get this, we will now integrate. And the rule of integration is you add 1 to the exponent, and the integrated exponent will be our denominator also. So the exponent is 2 plus 1 is equals to 3. So u cube, since that we have the 5 exponent, the 5 denominator here, and we have our integrated exponent 3, we will just multiply it to get our new denominator. So 5 multiplied by 3 is equals to 15. Put up a bracket from 2 to 3. Don't you always forget our limits because it is very important. So now that this is our integrated value, we will just substitute the value of u to the integrated value so that we can solve it later with our formula. So, what is the value of u? 5x minus 4. 5x minus 4 cube over 15. Put up a bracket from 2 to 3. So, this will be our integrated expression. Now that we have finally done integrating it, we will now solve it using the formula of the definite integration. Since you forgot our formula earlier, the formula of definite integration is f of b minus f of a, wherein f of b is the upper limit, and f of a is the lower limit. Now, we will substitute it so that we can solve the f of b and f of a. So, first, the f of b, 5, substitute the x. Our x will be our upper limit, which is 3, or the f of b, 3, minus 4 cube over 15, minus the value of f of a, which is the lower limit, or 2. 5, 2, minus 4 cube over 15. So, five times 3 minus 4 raised to the third power is equals to 1,331. 1,331. Copy the remainder. Or should I say, copy the denominator. I'm sorry. Copy the denominator, 15, minus the value of f of a, which is 5 times 2 minus 4 raised to the third power is 216. 216 over 15. So, 1,331 over 15 minus 216 over 15. When you are subtracting fractions which has the same denominator, you will just subtract the numerator and copy the denominator. So, 1,331 minus 216 is equal to 1,115. Copy the denominator, 15. So, we got our answer. So, the integral of 5 of x minus 4 squared from 2 to 3 is equal to 1,115 over 15. That's how to use U substitution. Since we are done with U substitution in our first example, now I have an example here which we will going to use U substitution, and then later we will change its limits. So, the integral of 2x, x squared plus 4 squared from the limit 0 to 2 is, first we will use U substitution. So, we let U copy this, we substitute this function, x squared plus 4. So, our du is this. We will use 2x so that we can cancel it out later. 2x dx. So the value of our dx, I tackled about it earlier, so I hope you get it. So our dx is equals to du over 2x. So now that we are finished substitutioning our u, we will proceed to solving. So, integral, copy the 2x. We let u to substitute this function. So, u, copy always the exponent. To the value of our dx is equals to du over 2x. Always, always never forget that. Du over 2x. From the limit 0 to 2. So, as what are you seeing? We have 2x. So, what we will going to do? We will going to cancel it out. Yes. Cancel it out. So, the remaining will be u squared du. But since we cancel out our x and dx and replace it with u and du, we don't have our limits now because our given limits were for the x and dx. So now we will change its limits to its corresponding values with the use of our limits earlier and with the use of our u. So we will use this to get our new limits, and so that we can solve it properly and it will be easier for us to solve it. So u is equals to, we will first use the lower limit or the f of a, which is the 0. Substitute the x, 0 raised to 2 plus 4 is equals to 0 raised to 2 or 0 times 2. Any number you multiply by 0 is equivalent to 0. Always, always remember that. 0 plus 4 is equals to 4. So, 4 is our new lower limit. Next, we use our upper limit or f of b, which is 2. So, u is equals to, substitute the 2 on x, 2 raised to 2 plus 4 is equals to, 2 times 2 is equals to 4 plus 4, 8. Our new upper limit is 8. Now that we change its limits, we can now integrate it. So, always remember that when you are integrating, you will add plus 1 to the exponent. So, u 2 plus 1 is equals to 3. That's right. Cube. And we don't have denominator. So, one of the rules of integrating is like you're copying the exponent, or we'll just n plus 1. Since our n will be 2 and we will add 1, it will become 3 also. So, over 3. Put up a bracket from 4 to 8. Since 4 and 8 are our new limits, now that we have integrated it, we can now solve it by the use of our formula. So again, our formula is f of b minus f of a, wherein f of b is our upper limit and f of a is our lower limit. So, we let u, what is the value of u now? Since we change our limits, so the value of u is the new limits. So, first we will use the f of b, which is our upper limit. So, substitute the u into the upper limit, which is 8. 8 cubed over 3 minus the value of f of a, or the lower limit, 4. 4 cubed over 3. So, 8 raised to the third power is equals to 512. Always copy the denominator. Minus 4 raised to 3. 4 raised to 3 is equals to 64. 64, bring down the denominator. As what I had said earlier, when you are subtracting fractions that has the same denominator, you only need to subtract the numerator and, yes, copy the denominator. So, 512 minus 64 is equals to 448 over 3. We will copy the denominator. So, 448 over 3 is the answer of the integral 2x x squared plus 4 raised to the second power from the limit 0 to 2. With the use of u substitution and changing its limits, we come up with this answer. So always remember that you are using definite integration to solve for the area of a curve on a plane. So, you can imagine it on a plane. This is the area which you've been looking for. That is the difference with indefinite integration. Because indefinite integration, you're only finding the antiderivative of a function, which you are always putting plus c or the constant. Wherein the definite integration, you are finding the exact, precise, and correct value of the area of a curve. So always remember that the true essence of mathematics is not to make simple things complicated, but to make complicated things simple. Thank you and God bless.